Hello everyone, and this is our third video on functions, which is relevant to both GCSE and A-level. And we're now going to be, in this video, talking about how we find the inverse of a function. And this is a really nice topic, really straightforward, some easy marks to be had here. But again, one that causes quite a bit of confusion for students. Now, an inverse of a function is essentially, it's like we're kind of like going backwards through the function. So what an inverse of a function is, so if we've got a function, we've got f of x, let's say, for example, there's our function f of x. So we go in, and what comes out is f of x. Now, what an inverse function is, it's what would you have to do to undo the steps that you've just done and get back to where you started, okay? So think of it as like reversing the process to get back to the original input. That's what an inverse function is. And the notation for an inverse function is, so for example, if we have f of x as a function, the inverse is written as like f to the minus 1, like that, okay? And if we say we've got an original function, that is if we had f of x as our original function. If we have g of x as an original function, the inverse is g to the minus 1 of x, like that, and so on. If we had h of x, it would be h to the minus 1 of x, like that. Now, it should be noted, this f to the minus 1 of x, it does not mean 1 over f of x. That's a common misconception, okay? It does not mean, this one does not mean 1 over g of x. That is a common misconception. This does not mean 1 over h of x, okay? It's a notation specifically meaning the inverse, okay? It means it's a notation for the inverse. Okay, without any further ado, let's have a look at how we're going to do this in one or two of these questions. So we'll start off relatively straightforward. Let's do question 4c. Okay, 4c. So we've got a function which is f of x is equal to 3x add 1 all over 5. Now, first of all, for this topic, we start off by replacing the f of x with the letter y. And just write 3x add 1 all over 5. There is our function. Now, at this point, teachers diverge into two different schools of thought. Some teachers now say, we're going to rearrange this to make x the subject. So your teacher might have said that way. My preferred method is to swap over the x and y and then rearrange it to make the y the subject, okay? But they're both equivalent and it makes no difference whichever method your teacher prefers. So I'm going to write down swap over the x and y, okay? So we're going to swap over the x and y. So that means we're going to write down x is equal to 3y add 1 over 5. So notice I've replaced the y with x and I've replaced the x with y. Okay, that's what we mean when we say swap over the x and y. Wherever you see the letter y, change it into an x, and whenever you see the letter x, change it into a y. Now, all we do is rearrange to make y the subject in the normal way. So I'm going to times both sides by 5. So I get 5x is 3y add 1. I'm going to subtract 1 from both sides. So 5x minus 1 equals 3y. And then finally, I'm going to divide by 3. So I have 5x minus 1 all over 3 is equal to y. And that is the process done of finding my inverse function, okay? Now, if I would replace the y rather, with the inverse function notation. So f to the minus 1 of x, the inverse, is 5x minus 1 all over 3. And that is our inverse function. Okay, really nice, really straightforward. We'll do one more of those straightforward ones, and then we'll do one that's just a little bit trickier. So let's do one more straightforward one. Let's do question 8d. 8d. Okay, our original function f of x is equal to the square root of 2 over x minus 1. So we're going to write that as y is equal to the square root of 2 over x minus 1. And then I'm going to swap over my x and y. So I'm going to write that as y. Oh no, when you swap over y, it doesn't change into y, it changes into x. X is equal to the square root of 2 over y minus 1. So I've now swapped over my x and y. So now I'm going to reverse. I'm going to try and make y the subject here now. Square both sides to start off with. So x squared is equal to 2 over y minus 1. I'm now going to times both sides, this can cause confusion sometimes, by y minus 1, and I'm then going to divide by the x squared. So when you've got something like this, when you've got something equals something over something, it's okay to swap those two around, and that in one go. All I'm doing there is timesing by y minus 1 and dividing by x squared, but it all happens in one go. I just think it saves a little bit of time to do that. So they've swapped places, okay? Now, if you're confused about what I've done there, I'll do here with the two steps. So step 1, times by y minus 1. So x squared times by y minus 1 is equal to 2. And then step 2, I now divide by the x squared. So you end up with y minus 1 is equal to 2 over x squared. So that's just to show you, if you prefer to do it in two steps, that's the two steps. And if you want to do it in one go, that's it in one go. But you can see you get the same answer in both cases. I'm now going to add 1 to both sides. So y is equal to 2 over x squared add 1. And that is my answer. Okay, so that is my answer for question 8D there. And finally, I just replaced the f of x with the right notation. F to the minus 1, the inverse of x, is equal to 2 over x squared add 1. Now, that's perfectly correct, and that is the right answer. But just a little note, you might see that sometimes, depending on whether you're required to write this in a different form, I'll write down here, or just another way of writing the same thing, f to the minus 1 of x. What you might do is you might think of the 1, rewrite that as x squared over x squared. This is just another way of writing the same thing. So all I've done is reimagined the 1 as being x squared over x squared. And the reason for that is because that now allows you to write that as 2 add x squared over x squared. So that's a different way of writing that, but they're both correct. And again, it's just if you have a show that, so you're aiming for a particular form, that's how you would change that one into that one. Okay, perfect. Now, let's finish this video off with just one more that is a little bit trickier, okay? And I must say that this particular question we're about to look at now is an exam favorite for GCSE in particular. Although this video is relevant to both A-level and GCSE, GCSE loves this one that we're about to go through now. And this technique we're going through comes up a lot in exam papers. So we're going to meet it first here in question 10A, and it's in question 9 as well, actually. But so f of x, they're telling us, is equal to 2 add 3x all over x minus 2. And we've got to try and find the inverse of this function. So we'll follow the steps that we've normally been doing. So we start off by writing it as y equals 2 add 3x over x minus 2. Then remember, in my method, we swap over the x and y. You know, don't worry about that if your teacher uses a different method. They're both equivalent and they're both fine. But I like to swap over the x and y. So I'm going to change my y into an x, and I'm going to change my x's into y's. There we go. So I've swapped over my x and y. Now, remember, we rearranged to make y the subject now. So I'm going to multiply both sides by y minus 2. So that gives me x, open bracket, y minus 2 is equal to 2 add 3y. Now this is what's tricky about this one, and this is why examiners love this. The exam boards love this because they know it. You know, exam boards are always looking to separate students into who can do what, and this is a little bit tricky for some students. So we now expand this bracket. So that gives us x times y minus 2x is equal to 2 add 3y. Now we're trying to get y to be the subject. So what we need to do is get everything that has a y in over on one side. And I'm going to get everything with a y over to the left-hand side. And everything that's just got an x in, I'm going to get over to the right-hand side. So let's do this one. Now I'm going to put arrows to show you what I'm doing. So I'm going to take away 3y off both sides. So I get xy minus 2x minus 3y is equal to 2. So all that's happened here is that's gone over to the left-hand side. Now I'm going to add 2x to both sides to get everything that's just got an x in over on the other side. So I've now got xy minus 3y is equal to 2 add 2x. So what's happened here is that one's gone over to the left and that one's gone over to the right, and that's where we are here. So we're getting closer now to being able to make y the subject. Now this is the step that students often really stumble and struggle with. The step we've got to do now is we now need to factorize, okay? So we now need to factorize this left-hand side and write it as y, open bracket, x minus 3. That's a really important step in this particular approach. So we've taken out a common factor of y. And then finally, we're going to divide the whole thing by the x minus 3 in order to get our final answer. So that gives us y is equal to 2 add 2x, dividing the whole thing by the x minus 3. And that is our inverse. Okay, let's write this down now in the appropriate notation. So the appropriate notation is the inverse is f to the minus 1 of x is equal to 2 add 2x all over x minus 3. And that's how we find the inverse there. Now you could have a little practice actually on question 10b and 10c and question 9 as well. Highly GCSE students that are watching this video, super important for you to be familiar with that technique. Very, very popular with examiners. And of course, we should need to know how to do that for A-level as well. That's a little video on the inverse function. Hope you found that helpful, and I will see you in the next, or finding the inverse of a function rather, and I'll see you in the next video.